Fairly recently, I found out something that is extremely interesting to me for multiple reasons. First of all, I found out that apparently three different scientists agree with my conclusion in the video quantum entanglement result. But not just that, though, they use completely different facts, scientific facts, to what I used to come to that conclusion. And still, not just that, they won the Nobel Prize in Physics for that conclusion, for my conclusion. So anyways, after the intro, I'll explain what I'm talking about. Here we go. I suppose I should start with a history that led up to the three scientists winning the Nobel Prize last year, 2022. In essence, they won the Nobel Prize for proving non-locality. Non-locality meaning that you're not limited by space, or in other words, that space does not exist. And this argument about space or about non-locality started back in 1905. Back then there was a conference, a scientific conference, which included Albert Einstein and Niels Bohr. And they had a bit of a disagreement about quantum mechanics. And their argument was pretty much that, non-locality, that Einstein insisted that quantum mechanics was incomplete, that it couldn't possibly be what it seemed to imply, that particles at extreme distances could instantaneously communicate. He insisted, because of his own ideas, that nothing could travel faster than the speed of light, that not even information could travel faster than the speed of light. So obviously objects, particles at extreme distance communicating instantaneously was very inconvenient for Einstein. But Niels Bohr was the main scientist that was arguing with Einstein. He kept insisting that it was in the math. The math indicated this, and that they were pretty sure that was the case, that non-locality was an actual thing. Einstein's idea was that there was a hidden variable, that somehow the information was already there within the particles before you separated them to extreme distances. The one example that I think explains this pretty good, that explains Einstein's idea pretty good, is the pair of gloves idea. If you have a pair of gloves, and you put one in one box and the other one in another box, and you don't know which one is on which, and they're separated by great distance, that when you open one box, you see that it's a left-hand glove, you automatically know that the other glove is a right-handed glove. That's what's, in essence, is called hidden variable. And but according to Niels Bohr, that not even the glove knows if it's a right-handed glove or a left-handed glove, that it doesn't know until you check it, until you absorb it. And when you absorb this one as a right-handed glove, automatically the other one will be a left-handed glove. Automatically you will know that the other one is a left-handed glove, but the information is not there. So Einstein's idea was called hidden variables. Niels Bohr's idea was called non-locality. And it stayed that way for quite some time. But in the 1960s, Dr. John Bell, a physicist, came up with a formula that should be able to proclaim one or the other correct. I would explain it, but I'm a little bit worried that since I may not understand it, that I won't explain it correctly. So anyways, this other fella, John Clauser, built a machine that would take Dr. Bell's mathematical formula and actually test it. And his machine came out saying that yes, that non-locality is a real thing, contradicting Einstein. But sometime later, I guess somebody realized that there was still that there could still be a hidden variable within Clauser's machine. So they came up with another way to prove the same thing, using Bell's mathematical formula. And so eventually there were three guys that proved it, each one better eliminating the hidden variable argument. And so the three scientists are Clauser, the one that figured it out in the mid-70s, and Anton Zeilinger and Alan Aspect. Those are the three scientists that got the Nobel Prize last year in physics. And I don't understand why the Nobel people didn't include Dr. Bell, because all three of those were using Dr. Bell's formula. There should be four people, right, winning it, but I don't know why they only awarded it to the three scientists that actually built the machine that eliminated the hidden variable option and finally proved that non-locality was a real thing, that space doesn't exist, at least the way we absorb it does not exist. So that's how they came to that conclusion. The way I came to pretty much the same conclusion is from a completely different direction, actually through Einstein's ideas. It took me a long time, I eventually came to that same conclusion. And in fact, I came to that conclusion about a year ago, about maybe, I don't know, 4 or 5 months before these three scientists won the Nobel Prize for that very same thing. Mine is, I think, a little bit more complicated. I didn't have two options to consider and eventually realized that one was right. What I had was Einstein's ideas coupled with an idea of mine that I came up quite a few decades ago. I think I might have even been still a teenager. I don't remember exactly when I came up with this, but the thing was that ever since I heard about it, ever since I heard the Big Bang and the scientists' explanation of it, I didn't like it. They seem to, within their explanation, contradict themselves. The way scientists describe the Big Bang has always bothered me. First of all, they say that the universe was extremely small. And then they go on to say that there was no space and time, or space-time. Why would it be small if there is no space-time? Why even use the word small when there is no space-time? There is no such thing as size. In this version of the universe, or at this point of the universe development, where there is no space and time, there's no such thing as small. So why describe it as small? This struck me as extremely weird. So I came up with different words to hopefully describe the same thing that they were describing. So what I imagine, not that the universe would be bigger, just maybe magnified so that I could mess with it, so that I could imagine it in my mind. I imagine the universe being this big instead of so small that you couldn't even see it. I imagine the universe being not this big but magnified so that I could mess with it, right? And when they say that the universe, that there is no space and time in the universe, what I think they mean is that anything and everything that happens in the universe happens instantaneously throughout the universe. If for whatever reason something happened on this side of the universe, it would instantaneously affect the whole universe, even in the direct opposite side of the universe. So in other words, there was no space and there was no time. So causality was instantaneous. And I know how, I didn't realize at the time that I was contradicting something that Einstein's, or or a small part of Einstein's idea at the time. I didn't realize, causality being constant always. But so I was imagining a universe where causality was instantaneous, which implied that there was no space and no time. And then for whatever reason, maybe because that's the nature of it, like the Greeks would have said, causality started to slow down. It was instantaneous, and out of the blue, it was not instantaneous. In other words, if something happened on this side of the universe, the effect of that event would take time to affect the opposite side of the universe. So in other words, the universe did not expand as they would describe it. Simply causality started to slow down. It would take time for what happened in one side of the universe to affect the opposite side of the universe. In other words, invoking space and time. So instead of the universe expanding the way they would describe it, it's simply that causality started to slow down. And so my idea was that not just at that point of the universe development did causality start to slow down, but it has been continuously slowing down till this day, till today, and further on into the future. So now, what scientists have noticed, the phenomenon that scientists have noticed and call dark energy, now I have an explanation for it. It's because causality is slowing down, but it's slowing down so slowly that we can only notice it at extreme distance from galaxies extremely far away, that we can't notice it here in our everyday life. So that would be dark energy, right? That's my description of the Big Bang. And at the time, I thought I was just using different words to describe exactly the same thing that scientists describe. I didn't realize until many years later, when I was reading a book, that it hit me that I'm saying causality is not a constant, like Einstein says causality is constant. Well, anyways, though, so that was pretty much the idea, and I've had that idea for I don't know how long. And so about a year ago, I don't know, maybe 2 years ago, I started trying to understand quantum physics, because I think the ultimate answer that describes gravity is within quantum physics. And I understand that scientists are trying to figure out why gravity doesn't seem to go in line or merge or somehow live together with the quantum world. I have an idea for that, but I'll leave that for another video because I haven't given it much thought. I need to think about it much more before I, make a video about it. So anyways, so now I'm trying to understand quantum physics. I actually been trying to read a book about it that I haven't been able to get into it. I think I've read at most like 10 pages because of what has been going on within my life with one of my kids being sick and all that stuff. So for me to relax, I try to think of this, with all the drama going on in this past year or two. So I'm trying to understand quantum physics, and it takes me a while to realize the first line in the book about quantum physics should say that everything glows. So I'm trying to understand. I'm trying to read this book. I'm trying to understand the double-slit experiment, and I'm trying to understand what they mean by spooky action at a distance, or so I have all this in my head. I'm trying to understand it, and then I realize that I've always had another problem that I've never been able to resolve. That I always thought it was a problem with semantics, right? It's just the words that I would rather use than the words that the scientists use. But then I realized that I've had that problem before, and the solution was actually a pretty good idea. What I think is a pretty good idea for dark energy, and how and why and what created space and time. So then I start thinking that maybe it's not a semantics idea. Maybe it's not just the words. Maybe it's maybe the answer lies within those words that I prefer to what they prefer. Okay, so here I'm going to describe another phenomenon, a very Einstein phenomenon that I think eventually led me to what I think might be the solution to spooky action at a distance and the weirdness of the double-slit experiment. So I've described this in a previous video. I actually described this. I used this description of Einstein's ideas to get people to understand just how crazy Einstein's ideas were at the time and still are today. I start by telling them that the light from the sun takes 8 minutes to get here, right? From our perspective, but that same light from the sun, from the light's perspective, gets here instantaneously. The light from the furthest galaxy away that we've been able to see, 13 billion light years away, takes 13 billion years to get here. But from this perspective of that light, it gets here instantaneously. In other words, for the light, for photons, for light particles, time does not exist. And not just that, but space does not exist. It traverses the enormity of space instantaneously. So time and space does not exist. And not just that, because photons don't have mass, then mass does not exist. So in other words, from the perspective of photons, from the perspective of light particles, the universe has not changed from before the Big Bang to after the Big Bang. From the perspective of light, there is no space, and there is no time, and there is no matter. So nothing has changed. So, in other words, this universe, from the perspective of light, is still extremely small, how they would describe it, scientists, how scientists would describe it. How I would describe it is that causality is still instantaneous, that the universe has not expanded or causality has not slowed down. And so I always had this idea in my head, who is correct? Are the photons correct that this universe has the same universe, that this same universe does not have space, time, or matter, or are we correct? Because we can see it, we can see matter, we can see space, we can, we live within time. Time, seemingly from our perspective, is moment by moment moving forward. So who is correct? Is the light particles, photons correct, or are we correct? And I always thought this issue was an issue of semantics, and I didn't give it much more thought. But about a week ago, it occurred to me that maybe the photons are right, and it occurred to me which of the two can prove that they're correct. Can we prove that we're correct, or can photons prove that they're correct? That there is no space and no time and no matter. And it occurred to me that their proof is quantum entanglement, spooky action at a distance. If they were wrong, if photons from their perspective were wrong, that there is space and there is time and there is matter, then how in the hell are they able to communicate with each other at extreme distances instantaneously? How in the hell can spooky action at a distance, what startled Einstein, how in the hell is that possible? But that they are correct. The photons have actual proof. They can prove to us that they're correct, that there is no space, that there is no time, and there is no matter, that nothing has changed from before the Big Bang to after the Big Bang. We are mistaken. So what the hell do we see? Space, time, and matter. What is this? What the is this? How can they be correct and we be wrong? Well, it turns out that not only can they prove that they are correct, that photons are correct, and we are wrong, but it also explains all the weirdness, or I don't know all of it, but some of the weirdness of the quantum physics. There's no space, no time, and no matter. The photons are correct. We are wrong. And our clue to them being right and us being wrong is all the weirdness of quantum physics. Spooky action at a distance, double-slit experiment. It actually makes sense now. It would be weird if there was no spooky action at a distance. It would mean that we're correct and photons are wrong. And when this occurred to me, it was like 2 a.m. I couldn't sleep. When this occurred to me, it actually scared me. So what the hell is this? What the hell is space and time that we perceive? If photons are correct, what the fuck is going on? What the hell is this? And I never liked the mini world explanation of quantum physics. I never liked it because I thought it was a shortcut a nonsensical shortcut to explain. I thought of it as very similar to how back in the a few hundred years ago, when they tried to explain as the Earth being the center of the universe, with all the planets making weird circles all around us, and the sun and the moons and the moons of Jupiter and stuff. It was too complicated. Where do they get all the matter for the other worlds, multi worlds? It couldn't possibly be, you know. And I think this explains it better. Photons are correct. Their view of the universe, they can prove their view of the universe. I'm struggling to find a way to prove it to myself that that our view of the universe has some level of objectivity, that it doesn't just exist, that it doesn't just exist within my mind.